Hello students, the last lecture we have seen the electromagnetic wave in a good conductor along with the skin effect. Now let us see the today's lecture on electromagnetic wave in a perfect dielectric. That is what in a previous lecture you have seen about lossless medium. This is a lossy medium where we are having a loss, right? It's called as lossy dielectric. So such type of mediums are nothing but gets attenuated. That is nothing but alpha is not equal to 0. An attenuation is there, not there, alpha is 0. If it's attenuated, alpha is not equal to 0. Such a dielectric is called lossy dielectric. Right? Now to propagate this thing, now let us consider one of the uniform plane wave which is traveling in z direction to the lossy dielectric, that is alpha is not equal to 0. For that we need to consider a wave equation for electric field vector E is given by del square E is equal to mu sigma dou square E by dou T plus mu epsilon dou square E by dou T square. 11. This is equation number 11.6.1. This is the wave equation for electric field vector E that is given by del square E. Now using vector identity on LHS of equation above, we get del square E can be written as del square E by del x square, dou square E by dou x square plus dou square E by dou y square plus dou square E by dou z square, and RHS will remain as it is. This is equation number 11.6.2. Now as we know that wave travels in the z direction, but E is the function of z and t only. So hence equation 11.6.2 becomes dou square E by dou z square is equal to mu sigma dou E by dou t plus mu epsilon dou square E by dou t square. Right? So these are three equations. Now let us move further. It's continued. Now let E has only one component in x direction, that is Ex. Then the equation 11.6.3 can be modified as, so dou square Ex divided by dou z square is equal to mu sigma dou Ex by dou t plus mu epsilon dou square Ex by dou t square. This is equation 11.6.4. Expressing Ex in a phasor form as Ex is equal to em into e raised to minus j omega t, then dou of Ex by dou t is nothing but j omega into em into e raised to j omega t, that is given by j omega into e raised to x. That's 11.6.5. Next again double differentiation, dou square Ex by dou t square is equal to j omega into j omega em into e raised to j omega t, so double times j omega. So therefore j omega square Ex, which is nothing but equation 11.66. Now dou square Ex by dou z square is nothing but mu sigma, so you put the value of dou Ex by dou t in this 11.6.4, that becomes j omega Ex plus mu epsilon j omega square Ex. Now after that dou square Ex by dou z square is equal to j omega mu into bracket sigma plus j omega epsilon Ex. This is the equation 11.6.7. Now these are some equations. Further we will continue. So by definition, this of propagation constant lambda is equal to root of j omega mu into bracket sigma plus j omega epsilon. Hence bracket value as omega square in equation 11.67, we get dou square Ex by dou z square gamma square Ex. So therefore gamma is equal to alpha plus j beta. Now gamma square Ex is nothing but 11.6.8 equation. So gamma is equal to alpha plus j beta. There is nothing but root of j omega mu into sigma plus j omega mu. So therefore 11.6.8 can be written as dou square Ex by dou z square minus gamma square Ex is equal to 0. Therefore dou by dou z is d and dou square by dou z square is d square. So then we get, so d square Ex minus omega gamma square Ex is equal to 0. So d square minus gamma square bracket complete Ex is equal to 0. This is equation 11.6.10. Now next, hence equating the inside term bracket to 0. So we get d square minus gamma square is equal to 0. Hence d square is equal to plus or minus gamma. So hence the solution of equation 10.6.9 is given by Ex is equal to k1 into e raised to minus gamma z plus k2 into e raised to plus gamma z. This is equation 11.6.11. Now where k1 and k2 are the constant with respect to z but with a function of time t. So k1 is em plus j omega t, k2 is em minus e raised to j omega t. So substituting the value of k1 and k2 in Ex, so we get em plus e raised to minus alpha dot e raised to j into bracket omega t minus beta z plus em raised to minus e raised to alpha plus e raised to j omega t plus beta z. This is 11.6.12. So these are the equations where we get in case of electromagnetic wave propagation in lossy dielectrics. Thank you.